So this time, we are going to prove mx plus b as x approaches to a is equals to ma plus b. We'll using epsilon delta definition to prove this. So for every epsilon greater than 0, there exists delta greater than 0. Such that if 0 is less than the absolute value of x minus a, less than the delta, then we will have the absolute value of mx plus b minus ma plus b less than epsilon. Then we will now remove the grouping symbol. Then we come up mx plus b minus ma minus b less than the epsilon. So we will just simplify this. Then it is resulted this as mx minus ma because positive b minus negative b is 0. So we did not include it here. Then less than epsilon. So since the common factor here is m, we will put outside m. Thus, we will have the absolute value of m times the x minus a less than epsilon. In our linear function, m is the slope of a line, right? So what happened probably to the line when m is greater than 0? Supposedly, it is increasing. Then when m is less than 0, the line is decreasing. So when m is 0, what happened to the line? So when m is equals to 0, this means the function is constant function because it is m equals to 0. So what happened when m is greater than 0? So the absolute value of m, x minus a less than epsilon, we will put outside the m. Since it is greater than 0, it is positive value. So we will put it outside. M times x minus a less than the epsilon. Then we will have the absolute value of x minus a less than epsilon over m. So therefore, our delta here is epsilon over m. So what if m is less than 0? So the absolute value of m is x minus a less than the epsilon. So we can put the absolute value of m since it is smaller than 0, lesser than 0. So the absolute value of m, then the absolute value of x minus a less than the epsilon. So we will have the absolute value of x minus a less than the epsilon over the absolute value of m. Therefore, our delta here is epsilon over the absolute value of m. So we prove it. So therefore, to get the value of limit mx plus b as x approaches to a is equals to ma plus b, you need to do the ordinary evaluation of a function, for we have a proof that through substituting the value of x in your function, then you can get the limit of a function. Thank you.